which are basically all the symbols we'll ever need to talk about geometry. We talked about what congruent means. Again, congruent basically is just the equal signs of geometry, right? If you want to say something is equal in geometry, you better just put that little squiggle over it. It means congruent, pretty much the same thing. And we talked about triangles and how if we write a congruent statement, so if I'm, and by congruent statement, I mean if I'm saying two things are congruent or two triangles are congruent, I have to match up their angles and sides appropriately, because if I move them around, that's not necessarily true. Right triangle, you guys know what that is. Again, an isosceles triangle is a triangle that has two of the same side lengths. Um, so an isosceles triangle would have two sides that are the same length. I tried my best there. That almost looks like they're all three. But if two sides are the same length, then these angles are also going to be um, the same. That's an isosceles triangle. And all triangles add up to 180 degrees, right? So if this was 50 degrees and this was 50 degrees, to add to 180, we know that this one up here, since this adds to 100, to add to 180, I would need this to be 80 degrees. Just a quick example. Okay. And we talked about line segments. Again, line segments are denoted by anything that has a line over them, right? We put 2 points and a line over them to distinguish, from where to where, which line segment are we talking about, and if they're congruent, they're just the same length, right? And then we talked about how in a diagram, you denote the same length ones, the congruent ones, by marking them, right? And since these ones already had one tick mark, these ones are going to have two tick marks so that we can tell that they're different, right? If we wanted to say that like these two are the same and we only gave it one tick mark each, well then that's also saying that they're the same as the ones up here. So to get away from that, we give it two tick marks to show that they're different than these ones, but they're the same to each other. So that was a quick overview. To move on to stuff that we didn't get to, angles. Congruent angles, much like sides, have the same measure. So if one angle is, I don't know, 30 degree, or we'll do it with the example I have there. We have angle BAD, which again, angles, you need 3 points to write angles now so that we know the specific angle we're talking about. And the angle that you're talking about is what the 3 points make. So when I'm talking about angle BAD, that's this angle here, because I go BAD, BAD, right? And we're talking about this angle right here. It is congruent to angle BCD, or this one, right? And if they're congruent, that just means they'd have the same measure. So I don't know, if this is 95 degrees, then that means this is 95 degrees, right? That's all we really need to know. Again, we really need to get used to, for angles at least, giving 3 points. 3 points are absolutely necessary because, again, if I just tried to say like angle D, well, am I talking about this whole thing? Am I talking about this side, or am I talking about this side, right? So that's why, for specifics, that's why you need all three. So maybe I'd say angle ADC, and then I would know ADC is this whole thing, right? So it just makes it really specific what we're talking about. So we need 3 points when we're talking about an angle. And then also when denoting angles, we do that little curve to show that they are congruent. So if I have a picture and I'm drawing on the picture and I said those two angles are congruent, to denote that, right, like with the lines we did the dashes, with the angles we just do these little arcs. So one arc and one arc would mean they're congruent. And then you guys won't be able to switch colors, but then how you tell other ones apart, right? Because if I did one arc here and one arc here, then that would say they're the same angle as these angles, much like as earlier, I said if we just put one tick mark here and one tick mark here, that also says they're the same as the two up here. So to differentiate it, we're going to do the same thing as we did before, and you put like two little angle things to show that they're the same. And then if we did the ones down here to show that they're congruent but different than the other ones, we'll do three little curves. That'll show that those two are congruent but not the same as either of these. And again, what we're doing now is I'm just kind of giving like a broad overview before we get into more specific stuff. So I'm showing you all the symbols. I'm telling you how we write everything, so that when we get to it, hopefully all we need is like a little bit of a reminder or reinforcement rather than teaching it all. Okay. So for parallel lines are line segments, or line segments are parallel if they do not and would not touch if they extended in each direction, right? We know what parallel lines are. They're lines that never touch. And if it's a line segment that ends, right, if you were to extend it out forever, would they ever touch? And if they do not, then they're parallel. And to say that line segments are denoted by, or to show in symbols that two line segments are parallel, you do these two little bars here, which we put the symbols up there. So what this says, oh, and I should go back to this real quick. Like on our Go Formative assignment, I did this with the triangles yesterday, but how this would read is angle, right? Because that means angle, BAD, and then this is congruent, so is congruent to, that says angle BCD. And that's all I'm looking for on that Go Formative assignment for like the first three, stuff like that. So back to this one. And to denote line segments on the picture, we do it by arrows on the figure. So notice how there's an arrow here and an arrow here. That's saying that this BE segment is parallel to AC, and it looks like they are. And if I happen to have, I don't know, let's assume that maybe I also had this line or something, and then I wanted to say these were parallel, much like the other ones, instead of just one arrow, that would say that it's parallel to these, which it doesn't look like it. We would do two arrows, right? And that says that we are parallel when we're talking about, or when we're looking at a picture. And then the symbol for it kind of makes sense, right? They look like two parallel lines when you write them up like that. So BE is parallel to, and then how you would write this one for our Go Formative assignment is that line segment BE is parallel to line segment AC, right? And that's all you need to type. On your Go Formative for ones like this. I'm just having you know what the symbols mean and how to read it. I want you to know that this is a line segment, this means parallel to, and that this is another line segment. So it seems easy, but I'm really just trying to get us like the basics, right? And so, for example, on this one, I just want us to be able to read, right, that this means angle BAD is congruent to angle BCD. I just want us to be able to read what we are talking about, because if you can't read or understand what we're talking about in the first place, then we're going to struggle. So I'm starting at the basic. Can you read the geometry symbols. That's what we're getting at. And do you know the definitions so that we can talk about them? Okay. Move on to the next one. Perpendicular lines. Line segments are perpendicular if they join and make a 90-degree angle. I've thrown that word out before, right, when we were talking about slope, perpendicular slope. Perpendicular, just like I said, makes a 90-degree angle. That's what perpendicular means. And the symbol line segments are denoted by two perpendicular bars. So for example, we said BD is perpendicular to AC. And if I were to write that out, we would say line segment BD is perpendicular to line segment AC, right? And the reason we do that little symbol right there is it makes it look like we make a little right angle. So that's the reasoning why we do this symbol here. And as we can see here, BD is perpendicular to AC, right? And we usually denote that by little right angle thing there. So BD is perpendicular to AC. And I do want to stress that it's not just because it looks like this, right? Because things can be perpendicular, right? You can have something like in an L shape and have them be perpendicular, right? You could have something like that, and these would be perpendicular, right? If I did A, B, and C, you could say AB is perpendicular to BC, right? It doesn't have to look like a line and then something down the middle. That's just how the symbol is, and this particular example, right? And they technically don't even necessarily need to be touching to say that they are perpendicular, but usually they are. So again, perpendicular, just drill it through. Perpendicular means right angle. It makes a right angle. And the symbol for it makes it look like it makes a right angle. So that's probably one that we've seen less of, is perpendicular lines. We've probably seen less of that word, and probably just a little less intuitive than the other things we've gone over. So make sure you're comfortable with those. Okay, just a couple more definitions, and these are things that are probably new to us as well. So two angles are complementary if they add to 90 degrees. So if I have, you know, a 30-degree angle and a 60-degree angle, those things are complementary because they add to 90 degrees, right? So if you had some sort of shape, maybe you had something like that, these two angles here would be complementary if they added to 90 degrees, right? Now supplementary, I'll put a C here for complementary. For supplementary, they have to add to 180. And so that's just something you kind of have to remember. So if I have a 120-degree angle and I add 60 degrees equals 180, right? So those two angles will be supplementary. And these will become important later on when we work with shapes and stuff, and we are trying to find out congruent angles and sides and things like that. We need to know this terminology. Now, I have a little trick for memorizing that complementary is 90 degrees and supplementary is 180. And it's kind of a silly little trick, and it might not work for you, but how I remember it is I know, right, the two numbers are 90 and 180. If I remember 90 and 180, I'm good. And then the way I think about it, complementary starts with like a C, and there's like one C in there, right? So that's 90 degrees. An S is kind of like two C's, right? We kind of have like a C this way and then this way, right? Like a backward C. So we have a normal C and then a backward C to make an S. So one C is 90 degrees and two C's is 180 degrees, right? If you double 90, you get two of them, right? 90 plus 90 is going to be 180 degrees. That's how I remember it. One C, 90 degrees, two C's, 180 degrees, but two C's is really the S, which, that might be so out there that it doesn't work for you. But that's how I remember it. And then lastly, a bisector is a line segment. So this is probably also a new one. A bisector is a line segment that divides an angle or a line into two equal parts. And that is new to us probably, but also pretty self-explanatory, right? Bisector, bi means two, bicycle, all that. So if we cut an angle in half, then this is a bisector, right? If these two angles are the same. And then if we cut a line into two equal parts, then the line that did that is also a bisector. So, and later on, you might hear more specific things like we might just say angle bisector, meaning it did it to an angle, right? And probably just a normal bisector if it's just lines.